Hello everyone, this is ASN Raju. In the previous class related to the mechatronics engineering, we have completed the control systems and one example related to the control system, that is waterhead filler, filling of the waterhead toward the towards the overhead tanker. And next, moving on to the application point of view regarding this mechanical speed control system. Here there is a second example, that is automatic speed control of a rotating shaft. So what is our main aspect of this mechatronic application within these systems? Nothing but decreasing of the human involvement indeed to operate in a perfect way. Nothing but filling of the tank. In the previous example we have been already seen that automatically the electrical power supply will be switching on when the water level has been reached to a minimum level, and hence this electrical power supply will be switching on the motor, and motor will drive the fluid offenses, nothing but the water from ground level towards the higher altitudes, that is filling the tank. After reaching the maximum point, that the level sensor will sense the water that has been reached to the maximum level within the tank and will give the feedback towards the control system, and hence the control system will give the signal or else cut off the electrical power supply to the electrical motor, and hence motor will be getting switched off. Hence the overflowing of water out of the tank will be getting eliminated. So here there is no any involvement of the human being, and hence the sensor plays a major important role, that giving a feedback to the control system, and control system which has been given to the processor as a command, and hence the processor gets alerts and switch off the electrical power supply to the motor. This is the scenario that has been happened in the previous example, and we will be moving on to the second example, that automatic speed control of the rotating shaft. Generally the shaft or rotating shafts will be seeing in an laboratory basis indeed to find out the efficiency or torque, or we'll be calling it as an RPM, rotations per minute. The physical parameter that has been utilized for finding this rotating element, or to find the RPM, is nothing but the tachometers. Tachometers, and it, there are two different types of tachometers here. First one, it is contact type of mode, and next one, it is an non-contact type of mode. So in that contact type of mode, this tachometer need to be get in contact with respect to the rotating element. Based upon that, the rotations will be getting passed to the connected tachometer, and digitally we will be notating the RPM, or else even in the analog format. Next, in the digital format, the electrical devices such as analog to digital controllers and even trans receiver elements will be placed additionally, that will be sensing without in contact with respect to the rotating element. The signals will be getting passed from the source into the destination is nothing but the rotating shaft, and that will give an electrical pulse to the controller, and hence the controller will translate the overall overall values with respect to the sensor and transit user, that is analog to digital converter and digital to analog converter, vice versa, and initiate the values in the LCD display. Here here the application of mechatronic system in this, there is an we'll be looking into it. Electrical power supply need to be switched on. Based upon the electrical power supply, the tacho generator will be getting rotated, and the rotation or the RPM will translate from this shaft, and the main shaft will be transferred or changing its direction with respect to the attachment here that has been mentioned in the bevel gear system, and hence this tacho generator will rotate the major motor, and this motor will identify the differential amplifiers. So amplifies the difference between reference and the feedback values. So reference value or actual value. What is the meaning of this? Here, they, based upon the given input power supply, tacho generator is being identified by contact within the contact of this particular system, bevel arranged system. When the motor has been rotated or rotating, the tacho generator will be in contact with the rotating element here, and this measurement will be giving as an feedback to the differential amplifier. That is, for a given power supply, input power supply, there might be a standard value of rotating element. That is, for 240 volts of power supply for 1 HP motor, there should be 320 rpm, or else 300 rpm, like that. There must be a default. So we'll be verifying that in the laboratory process or in the actual working scenario also. Here, if the similar value has been given as an input, then the motor will get energized and this shaft will be getting rotated with a similar rpm. So whether that default rpm is achieving or decreasing, or even it is over fluctuating or overriding, need to be identified. So hence, by giving the power supply to the motor, how much rpm is achieving, that will be getting identified by the tacho generator and give the feedback signal to the differential amplifier for measurement of the speed. And hence the default value is already fed in the system. The rotation element will carries the feedback rpm to the differential amplifier, and the error will be getting identified. And hence, indeed, to compensate the required rpm for actual work to be done in the industrial basis, there might be an increasing of voltage power supply. That is nothing but resistance value. By increasing or altering the resistance, we can monitor the rpm of that particular motor, and how much rpm we need to be set on there can be identified with respect to this contact type of tacho generator, which is already giving the feedback signal to the differential amplifier. That is the main concept here. We will be going on here. Potentiometer, that is nothing but voltage barrier. Potentiometer is the set of reference value voltage to be supplied to differential amplifier, and the main one, that is differential amplifier, here it specifies to compare and amplify the difference between reference and feedback value. Here, reference in the sense the main value which need to be obtained based on the input given to the system, and feedback value in the sense the tacho generator measures and will feedback to the differential amplifier. Here, there will be calculation, that isn't but comparator will compare the actually coming output with respect to the based reference value. Reference here in the sense 240 rpm, 300 already we have been discussed. 300 rpm need to be achieved, but here output 290 rpm only is getting, and then a feedback signal there is an error 10 rpm, and hence the 10 number of rotations need to be compensated. For that, here the voltage fluctuations are nothing but the potentiometer will be getting varied by increasing to some extent or to a minimal incrementing of the EMF generator. Automatically that 10 rpm will be compensated here. So the major aspect here it is indeed to find this reference or difference between the base already achievable value, nothing but default value, and the identified value is nothing but an instrument called, will be identified by an instrument called tacho generator. It is to measure the speed of the rotating shaft and to connect it to the rotating shaft by means of a pair of lever gears. This is one type of application in the mechatronic system. Simultaneously, in the domestical basis, we will be utilizing another one more application, that is washing machine. That is washing machine. So how the working will be existing in the sense there will be a drum, washing drum, which is connected with respect to a n number of devices such as a pump, valve. For pump is nothing but switching on the water power supply to the drum. Valve is nothing but the axis need to be moved or directional changes need to be done based upon the instructions given from the control unit. And next, if at all there is any heater necessary, nothing but heating of an water, then heater will be switched on, or else motor will be switched on for rotating the drum, rotation of the drum. For each and every aspect, there is an output. There is an output. Here, see, pump will be getting switched on, and hence output water level. So pump will be getting opened, indeed to work the or indeed to fill the water in the drum, and after achieving to a maximum level, and feedback device will give the signal to a where to the controller unit, to the controller unit that the level within the drum has been finished. Simultaneously, when the valve has value has been given. Value is nothing but 15 minutes, 20 minutes, depending upon the given cloths or cloths number of items of the cloths given into the drum. A value will be represented here. That value and the temperature need to be maintained. So here, hence heater will be getting switched on, and required temperature, if it is achieved, this water temperature level sensor or temperature sensor will sense the utmost temperature that has been reached and give the feedback signal back to the controller. Simultaneously, the drum speed. When the motor is switched on, the rotation in clockwise or counterclockwise, depending upon the electrical power supply utilizing. Hence, this sensor, speed sensor, RPM sensor will measure, and next will give feedback signal to the controller. Just now in the previous application, we have been learned previous two applications are existing here. What are those two applications? Here, first output specifies that water level. In the first application, in the previous class, we have been discussing regarding the water level. And next one, presently, now we are discussing this speed, drum speed, another one more. Just now in the second application, we have been discussing that RPM, tacho generator will give the RPM. And hence, the rotation of drum also will be measured by this RPM sensor and give the feedback signal to the controller. So this is the scenario that is being getting washing, rinsing, and next drying process. These three different methodologies. In the general foremost applications, or else the updated generations, almost that washing, draining is the fourth application, and next ironing, nothing but at a particular temperature, foldings will be getting done with respect to the ironing. And that fifth application also will be, or fifth step in this particular application also will be getting progressed. And for each and every one, the inputs has to be given in the control unit, and overall the process will be getting given in the set of instructions format, nothing but programming, and that program is also fed to the controller unit. So what are the depth steps that are being involved, we will be seeing in a sequence. First one, it is pre-wash cycle. It may involve some steps, that is opening of the valve to fill the drum with current is supplied or not, and microprocessor is used to operate switch for opening and closing the valve. That is nothing but to input the water and next off in the switching off the water. Closing the valve after receiving the signal from the sensor when required water level is filled in the washing drum. Stopping the flow of water after the current is switched off by the microprocessor. Switching on the motor to rotate the stipulated time. Here the clock will be setting, and next based upon that clock, the drum need to be rotated and initiates the operation of a pump to empty the water from the drum. So reverse cycle involves swashing the cloths in the drum by cold water. Second one, the main wash. The cycle involves the cloths in the drum by hot water and sequence of operations in main wash, such as cold water is supplied first initially after the pre-wash. Current is supplied in a large amount to switch on the heater for heating the cold water. Temperature sensor switches off the current after the water is heated to required temperature. Generally, in the previous application in this diagram that we have been already seen, heater and microprocessor or cam switch on the motor to rotate the drum after attaining a particular temperature. Finally, this microprocessor or cam switches on the current to a discharge pump to empty the drum. This is the second process, main wash. Third one it is rinsing. Opening the valve to allow the cold water into the drum, and the microprocessor given the signals to supply the current after the main wash cycle is completed. Switches off the supply current by the signals from the microprocessor. Operation of motor to rotate the drum in a heavy speed for rinsing, heavy speed. Operation of pump to empty the drum and respect this sequence of a number of times. Simultaneously, the three different steps will be progressing, and after draining the water, next one it is spinning process. Water from the cloths will be getting removed in the previous operations and switching off the drum or motor to rotate it at a high speed and then rinsing cycle. That is, even droplets also will be getting removed from the clothes. Later on, manually we will be taking and uh, switch, just leaving on, exposing on the sunlight. That is the main aspect. This is one of the example that for mechanical actions at 3 or 4 different steps, manual involvement is not necessary, avoiding of the manual power. Next one, engine management. He simultaneously here inputs and some of the inputs and outputs will be achieved in the case of this engine management also. See here, the engine speed need to be maintained, that will be fed back to the microprocessor for engine management system. Second input is oil and fuel pressure. So for necessary speed maintenance, oil and fuel also need to be observed. That is also need to be analyzed by a mathematical calculation by the microprocessor. Next one, how much temperature need to be existed. So whether the given material can be cope up with the highest temperature that has been generated in the engine or not, and how much temperature need to be achieved. That is the situation. Next, mass airflow, throttle position, feedback from the spark timings. The spark timings in the sense at most temperature, maximum temperature after achieving that will give the signals. And here there is another one more application. Spark in the sense minimum power supply need to be generated from the discharging of the battery at the initial stage of the engine. That is, for switching on the engine initially, electrical or DC power supply from the battery will be utilized. And next, later on from the spark plug there will be an reverse current flow for charging the battery. So that is vice versa. And here outputs, we are seeing towards the outputs. Spark timing, and there will be here in the power stroke there will be an spark timing and remaining 3 strokes for a 4-stroke engine. In the power stroke there will be an spark, and remaining 3 different strokes there will be work in progress. Next one, ignition coil drives. So whether that particular coil is getting ignited or not. Next one, fuel injectors drivers, solenoid drivers. That is nothing but electrical power supply. Indeed, to get the electrical power supply or charge burn, how much ratio need to be maintained? That is air fuel mixture within the carburetor. Next one, solenoid drivers. That is nothing but after completing this air fuel ratio mixture, the combustion process will be taking place where the high pressure and temperature will be getting generated, and later on upon giving the correct time of spark in the third stroke, the overall fuel will be getting burnt and valve will be getting input valve at the third stage or third stroke will be getting closed, and the fourth stroke will be getting started, and valve number 2 will be getting opened for exhaust, and hence the exhaust stroke will be getting commenced for releasing of the high amount of power that has been generated with a high temperature and pressure, and hence it will be getting converted by this particular engine from heat energy to the mechanical action. That is one factor here. So there is the engine management. This overall factors will be time basically monitored by this microprocessor, which has been utilized for engine management system, and this is also given in the form of a programming without any human involvement. That is increasing of the speed, that is nothing but applying the pressure manually upon the accelerator. Simultaneously upon decreasing, gear changes need to be maintained. So depending upon the temperature increment for diesel engines for a long drive, the water need to be supplied at the radiator. So hence this automatically verifies and pre-fills the radiator automatically, and mass flow air, and even throttle valves opening and closing, etc. Right? Next one. Here it is another one more application, that is automatic camera, which we are utilizing in our daily basis. That is digital cameras. Nothing but main switch is activated, shutter button activation to take a photograph, battery test, and range sensors. Range sensors and sensors zooming in and zooming out, interface circuitry, that is getting captured, contrasted, and next even the getting away objects, that is nothing but range incrementing or decrementing, zoom in and zoom out. Here it specifies the lens position. And next, light sensor, whether need to be LED flash need to be switched on or off, encoder with given lens position. When you have been switched on, practically you will be seeing when you have been switched on, automatically the lens position will be setting into an original position initially, and later on upon fixing a position will be giving a brightness brightness button, switching on the brightness button. Depending upon the contrast mode activation, you will be pressing and shutter button. Automatically the lens will be getting freezed, and snapshot of that particular image will be appeared in the display screen and will be sent for the saving to an memory device. In the similar application, the motor drives will assist the film that has been fixed within all the properties such as contrast, black, white, mode ratios, and color pigment variations, color variations, etc. And solenoid, electrical power supply, nothing but actuator to open the shutter out or close the shutter after completion of the tasks, simultaneously need to be closed away. And hence the lens position, for zooming in, the lens position have to be enhanced, or zooming out, That is nothing but again it need to be obtained to original position. There the motor need to be utilized. Next one, aperture control drive. Control drive in the sense our storing, if it has been freezed away after taking the snapshot, the drive will not be recalled it back again. And hence, for irrespective of momenting back side, the stepper motor will be utilized. Hence, our stepper motor utilization is nothing but back movement will not be getting commenced. And hence, here we are utilizing the stepper motor. After completing the entire task, the image will be getting achieved in the display and it can be viewed to a finder. So these are the some of the examples related to the mechanical systems. Initially, first one we have been discussed that level sensor, water level sensor. There, without any human involvement, the level will be finished out and automatically the motor will be getting switched off. Second one we have been discussed, that is washing machine application. Third one it is engine management system. Fourth one it is automatic camera. Not only this, we are having much more applications, even that is tram car application point of view and robotic devices that uses to transfer the material from one place to another place, that is conveyor belt system. These and all in the industrial field that we are being placed in inspection process and working scenarios, RPM maintenance, storage devices, identification of similar objects that has been manufactured, packing sections, labeling sections, etc. Right? That we will be discussing later, and how these identification is being progressed by utilizing different types of sensors. Here, sensors plays a major important role, and that types of sensors and what is the application of sensor in the robotics or even in the mechatronic system need to be operated that particular robots we'll be discussing in the next class. Thank you.